Sahar Vahdati is a professor of AI for Science at the TAB Leibniz Information Center for Science and Technology and at Hannover University. She is passionate about the transformative power of artificial intelligence and has dedicated her time to exploring its positive impact on life, humanity, nature, and the environment. She leads the nature-inspired machine learning research group, a cross-organizational initiative uniting expertise from Hanover, Leipzig, and Dresden. And her research focuses on advancing representation learning and foundational models with the goal of addressing scientific and societal changes, integrating AI into science and education, aiming to enhance learning experiences and accelerate scientific discovery. Everyone, Sahar Vahdati.
Good afternoon, and thank you very much, Tim, for the nice introduction. It's my honor to be here, to actually be back to community, because I was actually using Semantic MediaWiki during my PhD when I was working on creation and curation of knowledge graphs. Yes, today I will talk about some pillars of my research going on right now, which basically is on the role of knowledge and intelligence on the path from thoughts to actions. As I mentioned, I was for many years working on knowledge graphs focused with the emergence of language models. I'm working on how learning and reasoning of these two models could be combined, and we could actually benefit from their collaboration. I have a disclaimer because the talk for today would be heavily on the language model side, a bit of touch on knowledge graph maybe. There are examples that I used and they are outdated. I prompted a few days ago, but no guarantee that they could be today the same way. And thanks a lot, Tim. So you said that an excellent, oh, sorry, can we refresh and start, because I just did a small change. Just do a refresh and then. Let's see. Yes. So I had this slide later, but when Tim mentioned that a good talk starts with a puzzle, so I said, okay, let me just move it up. I will come back to this, but as my talk is around knowledge and intelligence, I just want to ask if anyone knows about ARC AGI challenge, the data set. Okay, one at least. Okay, so this is basically coming from a former researcher in Google. He is arguing that we need to measure intelligence of the systems that we are developing. I will come back to this again. And it's basically a data set of puzzles, riddles to solve. But each riddle is very different from the other. So what you learn when solving one riddle, you can carry that knowledge to solve the next one. So for a second, you can have a look on the upper side. On the left side is an input, and it's showing you what happened that you got the result on the right side, on the left side, basically. And from this is one example. From this, you have to solve the lower part of it. So there is a reasoning, the logic going on the upper side. If you decode that, you can solve the lower side. This is one task. Then you move to the next task, which has basically completely new logic that has nothing to do with the logic of this task. So he's arguing that if we are building intelligent systems, we have to build systems that are capable of skill acquisition, and they don't need a lot of examples. I don't need to show one example and to the next one for the system to be able to solve the next one. So we will come back to this. So for today, I'm calling these type of tasks as intelligent needed task, but we can also argue and have debates there. So the definition of intelligence is not that, okay, you don't need knowledge here, definitely. So we are agreeing on a certain extent of skills, and from there, let's call them intelligent needed tasks. There are also tasks that you need knowledge. So if I ask you the topmost philosophers from Germany, so we can consider Leibniz as one of the philosophers, mathematicians, so he falls into this category. This is basically coming from a knowledge. You don't need to learn over the puzzle way to be able to decode in your mind and come up suddenly with the Leibniz name, right? So here knowledge is the dominant things. I will move on with an example because we want to talk about the reasoning power of language models. So in my school time, communication between my teachers and parents in the school was heavily letter dominant, and we kids, we were the means carrying the letter between them. Some of the envelopes were very tight, closed, and some of them were open. This is actually a story that happened to me, one of my childhood traumas. We were going for a school day trip somewhere, and because my parents were teachers themselves, those letters would be very poetic, coming from Persian culture. And I would, if the envelope was not closed, I would have even, and I could read the text, I would have a hard time to even understand, is it about me or is it just a love letter between them, is so poetic and so on. So for this day trip, I actually looked at it and read it. When I asked ChatGPT to write with my prompt something that could basically come out of my father 45 minutes sitting there and being very picky how he's writing to my teacher about this, it would be something like this. And in my prompt, I'm saying that we are Persians, and I'm not saying where are we living. This could actually, if ChatGPT is creating this for a Persian family living in Germany, going to a school teacher here, this could end up with a lot of questions. That is, what is this about? Which was actually happening to me. I read this and I said, yeah, I'm allowed to go because the parents had to say. And when I was handing over my allowance letter and the teacher read the same thing and said that, no, it seems that your parents did not agree for the day trip, and I stayed in the school until they picked me up. I still asked them whether they wanted to allow me for that day to go or not. What is my point here is that LLMs are very, very good, and they are doing a fantastic job for reading and writing. Those letters that my father would write for his own, the parents of his own students and for my teachers could be done in milliseconds very nicely. I could also actually, you can do it in multiple languages, but of course the prompt should be a bit designed better. So this is fantastically done. And as I said, I would be switching between the tasks that are knowledge and intelligence needed. And a disclaimer again, I'm not saying that a person writing the letter doesn't need an intelligence. Of course, we will come back to this. But we are actually not dealing with reading and writing problems. In front of us, as I'm focusing and Tim mentioned, is much more heavier and more serious problems. The climate change, the misinformation affecting kids, which is every day a new sort of mental disease that we need to study for years to have some sort of mitigation or treatment for that. So all these things that we are dealing with are new challenges in science, and we can't really rely, no matter how we are very much surprised by fabulous results of language models, we need much more intelligent systems in the definition of this talk basically for today. In my job at TIB, as Maria Esther was also mentioning, a big part of my focus is also, as well as the colleagues, to build assistance, scientific assistance for researchers. It requires to come up with hypotheses and suggest new directions, not only by the next token generation, basically putting the words together, but having some intelligence and actually maybe even, this is where my talk goes from thoughts to actions, not only putting the words together and telling you that, you gave me these 5 PDFs and these are the research questions, but could actually say that if you spend time on this research question for the next 2 years, although it looks very shiny, you will end up with basically facing the wall, but the next 2 ones, I tested it, they are something that you could continue. And from there on, again, it's on the hands of human researcher. So I'm more focusing on practical tasks needed for humanity. And yes, so for these type of tasks, we need to build intelligent systems. And based on the commonly agreed, let's say, definition, such systems need to be able to generalize. They need to be able to instantly learn new tasks and also have solutions. They need to set some goals and achieve. I have my own fears about if what happens if they set a goal and achieve it. There I'm completely with you, but let's say that we focus on AI for good, because as AI for bad will eventually evolve, we need to have also AI for good, and we need to have the same skills, same approaches at hand. So this is commonly, partially commonly agreed, let's say, on the definition of AGI, artificial general intelligence, which for me is human-level competence across many domains. When we talk about these things, then the problem of language models falls into trustfulness for me, because they can hallucinate, they are very much biased, error propagation can be quicker than anything else, and of course they lack any sort of understanding and also robust reasoning. The list for why language models are having these problems, and longer list of problems, I could also list here a few pages, but I picked a few that I could show with this time I have here. They have information compression. They probably also trained on wrong data. Not everything is purely curated by human. There are missing domains, and of course these models are tailored to save money for the ones providing it. So they want to just satisfy the user as soon as possible with something that the user will say wow and just move on, right? So these are basically the reasons. For this, I asked one of the very recent models mostly used, and about 4 publications of myself, not because I wanted to basically promote myself here, just because I needed to quickly confirm that the result is fine. None of the 4 were basically correct. And this is basically where we are living with these language models. Although the letter that could be written by my father was very close to human level, very poetic, including culture, just by one word in the prompt. Here, for a simple retrieval task, it just hallucinates. The first one doesn't have the correct author list. It just eliminated 3 of my PhD students. Probably they didn't have a strong profile yet on the topic. And then the second one doesn't have a correct year. The third one is, I did it in 2019. This was one of the last papers in my PhD with a colleague, actually. And I wish I was working on more AI-centric and LLM in that time, but this has nothing to do with language models and loosely to actually core of knowledge graph. And the last one basically doesn't have a fully correct title. So be careful if you're using it for creating your CV or citations. So this is what we are facing. It's a black box, but what I could imagine for the first problem that I show you, that I guess the connection for eliminating my PhD students, what happened is that there are a bunch of, in the trained version, there are a bunch of papers, people, keywords, and they're basically probably strong connections from publications, my publication, to a certain list of keywords. And there are also people, if there are loose connections, then basically those dotted lines are eliminated. And it just simply hallucinates and removes them without factually wanting to look into what is on the web and the profiles, right? Because we humans, we think in pictures, so this is also another example to show you what's happening. I also asked the same model, what do you think a chair of AI for science at TIB Hannover and Leibniz University of Hannover is? And this is basically how this model is thinking. That's why I say it's really reasoning and understanding is nothing that we can trust. It's a very attractive chair, but it's not the chair that I hold at TIB. So Yeah, and this is basically also even problematic when we are dealing with information that is changing with time-sensitive data, and also when there is a low-quality web information that these models are basically finding, and the corpora they are trained on. I will slightly touch on System 1, System 2, but this is sometimes for some communities is the core that I go with. But what I think is that these models are doing is mainly we are still in System 1 category. They are very fast, they are unconscious, they just want to retrieve something, and this is what we are achieving. But for the actual problems we have in humanity, we need to seriously move towards System 2, something that is logical, has the reasoning capability, and always human in the center, of course. I actually, my relation to library, just fun fact, I was the youngest member of library in our town, so books are very important for me, and I always have some books in my slides. I don't know if you have read it, definitely recommend it. So with all of this situation, all of these problems, will ever LLM-based systems be reliable enough? It is based on the grounded truths that they are trained on, and that's basically the focus of this community that we have here, right? So it's extremely important that we keep human-created, curated, high-quality ground truths, because information is moving. We are dealing with a lot of new topics, worlds, and these models, if they are, as it seems, going to stay with us, at least for multiple years, until something even emergent is coming, then we need to have their strong connection with what you guys are basically creating. And that was basically the movement after 3 years ago, LLMs popped up. That was the movement that, okay, let's plug them in, that they can actually access those resources, the knowledge resources. And that was the retrieval augmented generation and knowledge augmented generation approaches plugged into language models to be able to query, to be able to ask a trusted resource. It can be the structured one, unstructured one, but have a source to basically double proof or access the information. I would like to a bit talk about one of our works, which is in this direction. The title is Beyond Boundaries, a human-like approach for question answering over structured and unstructured information. So the question answering was just a downstream task we chose. The approach here could be used for any other task, and it was in collaboration with Amazon Science and Technical University Dresden. So what is the problem of even after connecting language models to such external sources? Why the problem is not solved? Why there is still disability to give me 4 of my publication list just prompted yesterday? So basically, most of these language models are based on their parametric responses. Parametric means that when they were trained on those corporas, their weights and everything is saved. So it's not basically having access to up-to-date information. And it is trained to give the quickest reply. So you get what it knows from the past. It's very difficult to trace their trajectories of responses. And of course, they lack their recent and uncommon knowledge as we just touched it. So that's why these approaches came up with enhanced models with tools. The RAG and the CAG one that I touched a bit here basically allows access to those text corporas like Wikipedia, Wikidata, and also other APIs made available like weather forecast and so on. And basically, these kind of tool-augmented LLMs can query. However, they still face a problem because they fail when it is compositional query, or it gets a bit out of the comfort for them that they need to do more than one query or have a complex query. This is an example that we used at the time, I think it was GPT-4, that was returning the country, not the city, that was basically asked. And this answer that the president of Montenegro, Jakov Milatovic, was born in Montenegro is many senses is not a wise reply, because Montenegro is in the question. If I wanted to ask that, why I'm even asking it? So this would be very easy for human to immediately see that even if you read an article which writes the president was born in Montenegro, it's not exactly the answer for this question, because we know why. So presumably this the model is failing because it had a cutoff in its pre-training time, and its information maybe is not present in a right form in Wikipedia in that time, or the querying basically failed, or it was not reliable basically, and it's not hesitating to say I don't know, and it's basically trying to dodge the answer. Human would not do that, so that was our assumption. Even if you are asking a kid, which is part of my research now, we are asking the kids to solve those puzzles, and we are tracing how they are solving the puzzles. And this is giving us a lot of information on how the reasoning works for human and develops. Here, for such examples even, the kid would either say, I couldn't find it, or would try to say that, can I go and look into this book? Can I use my tablet? Can I use this and that? So you continue to browse as a human. You search for relevant other information. You combine the information and evidences and say that, no, this can't be the answer. It's the country, and country is in the question. And you even validate it as a human. So our idea was that whether we can let an LLM to learn to follow a procedure, the procedure that a human would follow, that would basically rather searching than retrieving from the parametric knowledge. And not only have one single query, but if needed, go for multiple queries, make it more complex. And for this, we basically also wanted to have an in-context learning because of the efficiency, because we didn't want to go back and train it on the updated information, update the weights, and say that, yes, now the model is capable. No one actually, only those giant companies are training the models, right? So the application we chose for this is the hybrid question answering, hybrid in the meaning that the model should be able to access structured and unstructured informations, knowledge graphs, and text corpora. This was what we did a bit with tests. So we followed the React called pattern. That's an approach. Basically, it's letting the model to go through 3 main steps in loops. First, you need to ask, what is my task? So I got this question. What is that I need to think about now? What is my next action? That is basically the step that the thought is generated, what to do next. The next thing is the action. You actually define what's my action, and the observation is basically the result that you get from the action. So this was our hypothesis, that if we can teach the model to follow this as human would do, then eventually would be able to say that, yes, it's not Montenegro, but I found the city name, or I couldn't find it. So here we started to lead the model to basically say that, okay, this is my task to figure out an answer for this question. So I need to find information about the president of Montenegro. It's really written a bit extensively by the model. I just needed to squeeze it in this slide nicely. But the action part is how you see it. The action part is basically saying that, okay, I need to access wiki search, and there I need to know who is the president of Montenegro. This is my first step. And the observation is basically to retrieve and to access this page and read through it, see if the information is there or not, which in this case was not. But what information we got, or the model got, is that who is the president, which is also a temporal question, right? So it is changing. So the model was capable of saying that, okay, I found the name of the Jakov Milatovic, who is the current president of Montenegro. And now it's still not the answer, right? So we need to try to push LLM not to give up here and hallucinate an answer output, but also go through another thought action process. Now, what is the next thing you would do as if you ask a human? What age? So, okay, I need to find information about this person, right? So the next action is to basically go and find the page of this person. I found it from Wikipedia, I read it, but the birthplace is not there. The thought is that I know a bit information about this person, but not yet about the birthplace. And for this, as we said, it is access to structured and unstructured information. So in this step, we also kind of instruct the model to try another sources. Another source is Wikidata, basically. Now write the query, and maybe this information that you are searching is there. So the model was here capable of writing the correct Sparkle query, and then retrieve the city name for the birthplace of this person, which is a relatively simple query, but still the model had the contradiction of the information from parametric response and the response that actually got from the query. But we had a step to combine them and say that now think about it, rephrase your answer and put it out. And this is basically the final answer was that Jakov Milatovic, the president of Montenegro, was born in the city of Podgorica. So I don't know if I'm pronouncing it badly. Probably yes. So two notes here. You might say that why not immediately when we get the question, like we used to, we create a Sparkle query. It can work, but it can also fail. The error rate could be high because if the query fails, if the construction of query fails, basically it's out. And also if Wikipedia had this information, we wouldn't need all of these things. That's true. That's why we need that ground truth. We need that human-generated correct information more and more extended. But still, for factual accuracy purpose, another validation with the system in this way to query and double-check, because there are also some not so correct curated information in Wikipedia, then it could basically have a double-check. It doesn't harm, basically. So we actually tested and it was working, but how now we are going to actually force the language model to follow a certain process, whether this is the process or another. So we needed to have a way to basically teach them. And this was the design we had for the core model, and we call it human IQ because it's coming from human-like way of solving it. On the right side, you see where we had the offline preparation. We had 2 workshops, basically, with human, two different groups, each 20, 30 people. We had to create examples of how human is accessing which tool when, and how this process is basically done for complex queries. And then on the language model side, for the inference part, which is basically runtime, then we tried to design the prompt in a way, as I said, to do it in context, because we didn't want to train the model. It would be extremely expensive. But having the prompt, which was actually, I still, for truth, I checked it if I remember correctly in the morning. It's just 15 line of text. That's our prompt, which is very efficient. Then we put everything in the prompt, the task specification, how human were solving it with 3 examples as few shots, and also a list of tools, which is over 50 tools, and all like listed that if you looked at this, then first start with Wikipedia. If you didn't find it there, then go to Wikidata. And the order was basically how human looked at it in the best case. Not blindly that, oh, this person just randomly first chose this tool, second, but we were basically asking our participants to write their thoughts that, okay, I first chose Wikipedia, but it was not there, then I went to this and so on. So we had even studied what is the order of the tools that the model should go. And then, of course, as this is on this side, what you see for the LLM inference. This was the time that we needed to fix the conflict of the model between its parametric knowledge and the assistant inference, which was also a generation step, final response step, and this was the model output to that question. As I said, we run two different workshops with people, and actually we also run a third workshop which was on the evaluation of the model. I will come back to this. We also not just provide the approach, but we have this UI. It doesn't matter if it is about question answering or not. As I said, you can design, you can study human, how they are solving a task, which I'm doing it with kids now for those puzzles, and then teach it to the model, basically. So this could be very well adapted. Yes, and I think, yeah, I touched basically all of what I wanted to say here. However, for the selection of the solution processes, we didn't need to create much. 10 to 50 of those examples would be enough for the model to see how the sought action observation is going on. But the selection of those by the model, because it's just the prompt saying that now, based on this question, find who did how the best action sought action observation. So we were not fixing. So queries come on demand, and the model should choose what is the closest solution processes. For this, we actually, the prompt design was very important, and then we use this terminal point process. Basically, it is giving you the chance of choosing very similar to what the task is, example, but also have it not exactly, very far and very similar. So this was basically the way we guaranteed that the model is not biasing by choosing very similar tasks that we had. And we basically integrated full solution process in the prompt, as I said. And this made the model not to just do a single tool call and stop there and dodge it, but to continue. The evaluation, we chose the task-specific hybrid QA baselines because that's the downstream task we deal with, and also existing language models in that time. And we reported it on EM is the exact match, how many of the answers are exact match of what we retrieve with human IQ and those approaches. We also did a manual validation. That was the third workshop in a way. No, that was not a workshop. That was done by co-authors. We basically, when you use those automated metrics, we just observed that they underestimate the performance a bit. So just to see that how really like our model is, our approach is shining, we went one by one over, I think, 500 questions. This was very difficult for my PhD students, but they did it in a way. And all these results are 1 out of 3 data sets that we reported here, but you actually see that we can see the difference of human IQ with ChatGPT 4. That's quite a difference. It reached 91% on this data set for accuracy. We also looked into the error rate. So each of those arrows, the percentage minus 100 is basically saying how is the error rate there. So that is where the 16.6 for ChatGPT 4 and 8.2 for us is coming. It's pretty like almost half of the error rate was there. And this was also one of the nice, this is the third one. The third workshop, I mean, that I like to do because we define several criteria. As I said, I squeezed the text returned and those thoughts, actions and those texts here for this slide, but it's actually extensive when the model is actually talking to you. And we wanted to also assess how likely or which of the answers they are preferred by users. We also did a workshop which we didn't have any overlap of those participants with the 2 first ones. And we asked the the participants by presenting both human-generated answer and our system-generated answer, both as system-generated. We said that we have two systems, and they are basically, for this question, the system 1 is saying this, and system 2 is saying that. Which one you prefer? And in 45% of the answers, our answer, or basically the answer by human IQ, was preferred, and the other way around was only 8%. The rest was pretty, they said that we can't say, is pretty close. The criteria we defined was correctness, informativeness, and several others. We were giving the definition on top for them, and we were basically giving also 2 examples, saying that this is an example, now you have to judge for these 2 answers. Also, because updated information is very sensitive, and most of those models are failing, as we saw it in the list of my publication, although it's a changing list, but some of it is a statistic, right? So we also figured out that 36 of those questions in this data set, in these 3 data sets, basically could have time-sensitive information in it. And this was the very surprising fact for us, nicely surprising, that human IQ had very robust way of dealing with the information that was changing on the web, on Wikidata and so on, and get it correctly back than the normal base models, the vanilla models. And this was very naturally bigger margin. So back to the pillars of my talk today, as we went through, like, for such question answering, you need to have the ground truths. For the puzzles that I were mentioning, is basically the skill acquisition, how fast you can, and with minimum number of questions, you can basically solve one after the other novel task. LLM solve knowledge needed task, yes, but there is a big if there. It is only if the grounded and high quality corpora is there. So in September in Dagestul, we had very much a seminar, which was, I think I could imagine any of you enjoying that. And there were a few of the librarians and Wikipedians and worrying that will we be replaced by AI, and as never, I think, because the truth is among us and in these communities, and these models would be basically done without such contribution. So back to what Tim also said, yes, please do whatever you can, and it will be a big contribution. Now the flow of this evolutionary models and approaches one after the other is moving to what you also have heard, agentic systems. And as I say, so probably in this green arrow could be stretched, and there are a few others popping up, but eventually we are actually really talking about how and when we are, if not yet, having AGI among us. And for me, it is really about what is the task? Do we need knowledge? Do we need intelligence? Are we dealing with novel, new problems or not? And that would be the place I would have the puzzle. Did you decode the reasoning behind? Yeah?
So the colors, you gotta look at how many, what are they called? I guess circles are in there?
Mm-hmm.
And holes are in there.
Yes.
Right?
Yeah.
And then if it doesn't match any of the number of holes, it just straight up disappears.
Yeah.
But yeah, you can see like the ones with no holes become yellow, etc.
Exactly. So there is a coloring pattern from left to right. Of course, for the gray objects there, the objects are having different dimensions, but the point is about those holes. That is basically, this is the color code, the guidance. And here, the change is that now the color code is above is 4 colors you get, below is 3, and it is the other way around. So now ask a student do this, probably fraction of seconds, and on this data set, human performance is 85%, And what actually last year, every November is the close-up of this challenge, and they open again. And last year it was 45% for language models or language model-based approaches, and the challenge is not closed and it's going on. What happened is that they introduced another data set, which is interactive games. And what matters here is in this purple dots above, it is saying how many attempts you have, how many moves you have. So you can move up, down, and solve it. And if you are not able to do it in that number of attempts you have, it just reloads. So that is what I'm basically doing with kids of age 8 to 14, kids, teenagers. And I can tell you that if something is going on there, they are outperforming adults in a way. And we are trying to see what is it. Probably it's the overthinking that we have, how to solve it. And the kids are just diving in and saying that, let me try this and that. And after a few attempts, what they learn is that to check and not to make decisions too quick, but dive in and solve it. So we are writing the paper, and it should be out end of November. So what's happening with those frontier AI models? That is where human is standing, and there are only 6 of those games. End of November, there will be publishing 100 of those games, and this is where AI is basically, even not 1%. So a lot of hope, a lot of things to do. And imagine now you want to ask these models to solve climate change or misinformation, mental health, and all of those things. So forget about it. So we have a lot to do. So back to why I named the title like this. That is what's happening now. All the talk about those retrieval, and we can actually contribute and make it more factual towards agentic AI. We want them to do also something, to run a small experiment that I don't need to spend a month. Tell me that if after spending 2 months on this, my student will come and say that I can't get rid of this error, give me another topic. Or you can actually get this within hours and say that, okay, now go and do the actual work of the research. And I'm aligning it, a big part of my group is working on solving ArcAGI dataset, because we have to measure those systems that we are building. Now back to TIB. My research is also, of course, contributing and building systems for assisting researchers at TIB. From TIB to the community. So what's happening is that, yes, great, you can go to ChatGPT and ask and say that these are the 4 recent publications, give me research questions. It will give, and you will say that, well, I would probably not come up with these research questions. That is what is going on. We also touched a bit on the problems, and it's actually helpful. I'm also fully allowing with control my team to use it, myself as well. But this is where we are moving from TIB assistant for TIB scientist. That is 2 of my PhDs are working on this part, executable science. This is a bit of not the core that I touched here, but why I'm spending so much time on ARC, because we will need to evaluate. We will need to say that if this system that I'm telling you use for evaluating your initial research question, how you can trust this. So basically, if such a system is capable to deal with ARC data set, that's an indicator. That's not the final stop for us, but that's an indicator to say that, okay, we can trust what is the system is saying to this extent about science. Yes, with that note, I actually conclude my talk. We need to work on measure of skills, measure of intelligence. There are tasks clearly that needs both of them. One heavy in one task and another heavy in another one, depending on what we are dealing with. And yes, let's build AGI that strengthens the knowledge commons, not that it's going to replace knowledge commons. As I said, I'm a big fan of books. My postdoc brings every week new books, titles, not the book itself. And I'm reading this book, and I would highly recommend to have a look into that. That's one of the books that I have for a long time not read such a book. So thank you very much. Yes, I'm ready for questions and discussions.
Hello, my name is Ben. If I understood your talk quite well about the model, you talked about where the birthplace of the Montenegro president, and the right answer according to your model was Podgorica. Yes?
Yes, that was our observation at the time.
Yes. But the real thing is, he was not born in Podgorica. He was born in Titograd. That was before Montenegro was there.
Okay.
So that would be the next level.
Exactly.
Yeah?
Yeah.
And you can find this in Wikipedia.
Maybe recently we need to look into the history.
I will do that.
Yes, definitely, because that is basically the query we run and have it. And that is exactly why we need human in the loop.
Never forget history.
Yeah, exactly. No, I totally agree with you. Thanks a lot. I'm going to include this in the way you mentioned in the next talk. So, yeah, that's it.
Hello. Are you aware of the Spinach Wikidata chatbot?
I think I got a link, but I haven't used that.
Oh, okay. Cool.
So, do you know about the methodology behind the chatbot? How does it work?
Ultimately, it creates a Sparkle query for Wikidata similarly to the approach, I guess, that you have. I don't know what the differences are, though.
I believe they didn't use, or are there people behind that chatbot here? I would be very interested. Probably the difference is the follow-up of the React pattern of think, action, and observation, because creating a Sparkle query is not what we contributed. It's just one of the tools that if the model thinks that, okay, now I need to query, then it's writing the query. For some of them, it doesn't need to write a query, it looks into other APIs.
Hi, so you made an intriguing reference to Kahneman's work, which I've never seen cited in this context. And I think that the idea that LLMs are sort of heuristically using system one thinking, it seems to make sense, but do you think that we will ever be able to approach system two thinking just by having knowledge needed tasks, as you explained? Or do we need to input intelligence needed tasks or questions for that as well? And where are the limits basically of using LLMs for the kind of processes that you are working on?
I think we agree, yes, and Kahneman's book was heavily used in AI community, so I'm not the first one. You can have a look on Yoshio Bengio's books and papers. It's heavily influencing AI, I would say, since many years. And I do agree with you, and I don't think that it's about system 2 achieved. That's the point. That's why I had system 1 basically colored, and system 1 not, because I don't think this is the way we will have system 2, and that's why we don't have it. That's why we need, and this ArcAGI with this interactive games is giving a way to you that first the model needs to think, reason over it, but also act. Model needs to, when it made a decision that I need to move this object up, actually needs to move it up. And another day we had a question from one of the known professors that then why you are not using reinforcement learning? This environment is unique. It's not about learning as like Atari game that I will hit the wall and then, there is the window there, I should jump there. No. This environment doesn't have anything to do with the next environment. So reinforcement learning is out. And I do agree with you that, no, I don't think we will very soon be there for system 2, but there are a lot of nice initiatives, including the one that François Jolet started, working on it, and we need to work on it, yes.
You may have explained this before, you probably did, but you talked about time-sensitive information or queries or something. Could you explain what that is?
The change of the president birth date is, although it can be an static fact, it's not by nature temporal, but it's actually, it changed. This information pretty sure was there, and someone came and had the knowledge truth and corrected it. But there are also, who is the president, the name of the person also even. So we had this data set we use, this Mintaka. It is based on Wikipedia. It has a lot of those questions about football players who are playing in this club and next month paid better, move to United Arab and so on. So yes.
Hi, I'm sorry, I must have missed something, but did someone say that current LLMs are not able to do System 2?
Yes, we actually agreed that they are not able to do System 2.
Uh-huh.
You might think that what then, I don't know if you know about Magnus AI, that they are providing some actions and so on, but I don't think it is, it's too vast System 2, but System 2 is not there yet.
Okay, so I'm just curious then, what do you consider like the reasoning models that OpenAI and Anthropic are releasing, like, you know, O3 for instance, O4, they consider it to be reasoning, and, you know, intuitively one might think that it is System 2, but it sounds like that isn't a System 2 in your opinion, and if so, why not?
I mean, those systems are still generating a lot of nice code that you can do. I was myself a month ago when I was playing with Cloud Code. I last year had a project. I had a front-end developer, a back-end developer, a designer, and 6 months it took us very efficiently to design an app for solving puzzles, again, anything around puzzles. And then with Cloud Code, I had, I think, 5 pages of description of my discussions that you have 3 roles, you are a designer, you are this and you are that. And for me, it was shocking to see that in my computer, it started to create a folder, put the coding inside the folder and all of those things. But can it actually reason over the code generation and actually run it, test the software, and do all of those things? For me, it is one level later. I do agree in reasoning recent years, all those companies are making progress. We can't be blind, but I think it's still far from System 2. System 2 is basically you get this model who is driving in Germany and go to UK and immediately is switching basically the position in the car and adapting there. I don't think they are still fully System 2.
Wait, I'm confused. So you're saying that even though Claude Code was able to do, you know, end-to-end testing and all that stuff automatically, you still don't consider it to be System 2?
Not fully, no.
Not
I think
fully.
it's still generation. It's still creation of something. It's not capable of then doing something out of it. It has action in it because it's accessing an environment after my permission, creating the folder and all of those things. But it cannot test the hypothesis. It's still far to my opinion. It's a personal opinion.
Okay. No, this is a very good opinion. So this is the first time I've heard of this hypothesis, and it's certainly worth rethinking. So thank you very much for that.
Same. I will also think. We can discuss.
Yeah, go on. So I am very, very slowly following along. So when you were asking the LLM to follow this human IQ-like process that you had, is it following that still by spitting out like English words and using that to reason about what the next step it's going to do is, or does it kind of symbolically know that its next thing it has to do is do some search online? Does that make sense as a question to ask? I'm not sure if it really does, but it feels to me like internally is this thing just chucking out yet more English language strings which say, I mustn't forget that I need to do this, and then it reads back over it? Or has it got some kind of more like hard-coded restriction that it has to do this?
Yes, no, we don't have an influence on that, but it's all latent space. So they have an understanding of the latent space, the vector, which is very different than the vectors we have in knowledge graph and their association with words. It's a black box. I'm actually with one of my PhDs working on the latent space thinking of LLMs, but for these ones, I think our interaction was word-based with the model. What's happening behind, I should be employed in OpenAI to tell you.
Oh, okay. Cool, thanks.
Just thinking about the answer we hear about Montenegro. Do I have to switch something on? Oh, okay. I think the answer was not wrong. I think the prompt was inaccurate or not.
Please speak into the microphone.
Okay. I think the answer for the machine wasn't wrong. I think the prompt wasn't inaccurate. Because a name changes in time. The place probably is the same. And if we had asked him in another way, in which city in a time period he was born, then we probably find the right answer. That's just what I'm thinking. The machine in this, that is not a problem of the machine, that is a problem of the prompt, for me, at least.
It can be several reasons. It can also be that, I don't know, like right after we put the slide and had the evaluation, someone went and changed it, and we actually have only the information until 2 hops that the model did the sought action observation. I think to notice what happened, I need to check the story. If this information was on Wikidata with this name that you said, it was?
I think it's a matter of priority.
Yeah, could be.
In this SQL study.
Yeah.
No, I'm going to look into that, so what happened. It can also be that we chose, the wrong name here, but I have to check. It was a good point.
Yeah, I don't know. I'm hoping I'm going to re-ask a question to clarify this, because I think what the gentleman over there was saying wasn't that it's the wrong name. It's the same city, but it used to have a different name when he was born there. So that's somehow subtly different, kind of. Does that make sense?
Yeah, that makes sense, and
Yeah.
I need to look what happened to this
that's
very
what I was
example.
gonna ask, yeah.
So we could debate on this example, so I need to check what is, actually my message is that we can teach a model to follow how human is thinking, which is more trustworthy.
Sure.
And we can actually design a certain way of thinking, and we can actually, without training the model, we can say that follow this now, and it will do it, because it was not one example, it was over hundreds of examples where we did the study. Also even manual check of what we have. This truth that we have, we trust that this is the truth. If someone knows better truth than this, then that's why we need to update that ground truth, right? So, but I think we know what scenarios could happen that this example went wrong. That doesn't devalidate the approach was completely wrong. So that's my message.
My passport, and so it says when I was born, I will not tell you, but where I was born, that was in Amsterdam. That is a small place.
Let's put this discussion from the coffee break.
That's why.
Let's just have this.
Sahar, thank you very much for the super interesting talk.
Thank you.
I have one spontaneous question for you. Do you imagine that maybe coming up with really original research hypothesis could also be an interesting benchmark for building better AI? Because from my experience so far, trying LLM chatbots with this, they are not very original. So is this maybe something that we can expect, or would this require like a major step which goes beyond what we currently have with large language models? I would be interested in your opinion.
I do have those ideas, but for evaluating how good the benchmark we actually create, we need a major involvement of human collectively to make sure that we all agree those are novel. We can't go back. We can use the ones from history, proven. There are lots of theories. But the problem is that these models have seen it. We cannot eliminate this knowledge from them. Maybe if we have some certain circumstances, we can also test that. The point is that what are those, like what is the, like 100 very novel hypotheses that is hundreds of people agree, and these models could be basically, we could do something around those. The evaluation is human dominant highly, and with certain profile, I would say. It's a direction we have to go. That's why I really think it should be human heavily in steering and in the loop for all of those directions, and we need to do that, but where do we have that lever?
Thanks. I just really want to thank Sahar and actually give a proper applause.